All right, guys, we're going to solve this little example problem here. It says Karen believes she has received imperfect service from many restaurants. In fact, she's had to ask a manager in 12 of the last 20 restaurants she's visited. Create a 90% confidence interval for the population proportion for Karen needing to ask for a manager. All right, well, this gives us three pieces of information. It tells us how many restaurants she's visited. It tells us how many of them she's had to ask for a manager, which we'll use as our level of success. And it's going to give us a 90% confidence interval. We need to decide, are we doing a population proportion? Are we doing a population standard deviation known? Or are we doing a population standard deviation unknown? Well, if you read through this entire example, never once does it even mention the word standard deviation. So that should probably give you a little clue that we're talking about a population proportion. Another reason is literally it says population proportion. Probably most importantly, though, is that it gives us a proportion. It gives us 12 out of 20. So let's go ahead and write down all the information we know. First off, let's write out our confidence level. Our confidence level is going to be 90%, which we can kind of just call 0.90. Okay, that's going to be very useful later, but let's move on. It tells us how many successes we had, so let's go ahead and write that out as well. X is how many successes, and the number of successes were 12. 12 times she had to ask for a manager. All right, our sample size is going to be on the next line. Let's call our sample size n, because that's what it's been since day one. And our sample size was 20 restaurants that she visited. Well, in order to solve this, we're going to need our p hat that is found by taking x and dividing it by n. So p hat is equal to, it's going to be x over n, which is 12 over 20. So we will do x over n, and that's going to be equal to 12 over 20. I can already see this is going to need to be a little bit bigger, so let's go ahead and make it a bit bigger here. There we go. All right, and now we need to find our standard error. Now, standard error is typically defined as sigma of x bar. So there we go, sigma of x bar. And that is going to be equal to, and this is kind of a strange one, it's kind of big, so it's going to be the root of the proportion of p hat, so there's p hat, times q hat all over n. Okay, well that is going to be equal to, well, we know our p hat is 12 over 20. Well, we never actually found what 12 over 20 is, so let's find that real fast. So 12 divided by 20 is going to give us 0.6. We also know that q hat is just 1 minus p hat. So 1 minus 0.6 is just going to be 0.4. So let's actually write that out. So q hat is equal to 0.4. All right, well, that's going to help us out in determining our standard error. So our standard error is just going to be this all filled in. So we know that p hat was 0.6, q hat is 0.4, and n was 20. Well, 0.6 times 0.4, that's just 0.24 since 6 times 4 is 24. So let's go ahead and change this to 0.24. and n we said was 20. Well, let's find out what 24 over 20 is, or 0.24 over 20. That's going to give us 0.012, and we're going to have to square root that. So we're going to do the square root. Said it was 0.012. That's going to equal, let's find out, 0.1095. Let's call it 0.11. So it's approximately 0.11. All right, that gives us our standard error. Well, now we need to know our Z confidence. So we are going to go ahead and put that in here. Z confidence. And Z confidence, as we know, is going to be a constant based on our confidence level. And if we look up what 90% means, we will say that 90% is 1.645. So 1.645. We've already covered how to find Z confidence earlier. Last thing is we need to find our E, which is our standard error. No, it isn't. It is our margin of error. And our margin of error is going to be equal to our standard error times our Z confidence. So we have standard error times Z confidence. And that is going to be equal to 0.11 times 1.645. I don't know that off the top of my head, so let's multiply them. And we get 0.18095. Let's call that 0.18. All right, last thing we have to do is take this 0.18 and both add it and subtract it to our p hat. So 0.6 plus 0.18, 0.6 minus 0.18. .6 plus 0.18 is going to be equal to 0.78. And for the lower one, 0.6 minus 0.18 is equal to 0.42. So we have our big one and we have our little one. Last thing we got to do is put it in the context of the problem. Remember, we're talking about asking for a manager. So we would say, quote, we can be 90% confident that the population proportion of likelihood that Karen will need to speak to a manager is between 42% and 78%. Remember, your confidence level goes here. Your subject matter goes here. Your lower part of the confidence interval goes here, and your upper part of it goes here. Thanks, guys.